Hey guys, today's video is going to be about something called the rule of 4, and we're going to do a little bit with comparing functions. I actually have a special guest today for our video. They are my sons, Anderson and Connor Wu. I'm going to let them say hi real quick.
Hi. Hi.
So that was Anderson and then Connor. They just said hi. And so now they're going to go and finish watching Chicken Run, the movie. So getting back to our video, the first thing that we're going to talk about, this rule of 4, and I've kind of mentioned, you know, we've dealt with equations at the beginning of the unit. We have also done some graphing. We have also worked with tables and story problems. Today we're going to connect all of that together, and that's why this is called the rule of 4. So if you think about it, we have story problem, equation, table, and graph, so all 4 aspects. So if we start with this first example, Hans needs to rent a moving truck. We have company A has a rate of $40 per day. Company B charges a $60 fee plus $40 per day. So what we're going to do, so this is like the story problem part of this one. We're going to write an algebraic equation for the total cost, C, based on the number of days, D. Okay, so instead of using X and Y, we're going to be using C and D. So in this case, if I kind of look at everything on my notes, just glancing at the table, I can see on my table right away how they have the days and the total cost labeled. So typically, whenever you talk about time, doesn't always work, but I would say time is usually X, while total cost is usually Y. There's always different, story problems where it may switch, but that is kind of a good rule of thumb. So we're going to remember that as we write our equation. And then you see I put it in for the table just to kind of help us. The other thing too is when we are making these equations, we're going to remember we're going to put everything in Y equals mx plus b form. So company A, they have a rate of $40 per day. Per means to multiply. Okay, so it is 40, and then we're going to multiply it by D. So again, days are D. Then for company B, they have a $60 fee. Okay, so I'm just kind of writing what I'm reading. So $60 fee plus the $40 per day. Okay, so this is a little bit backwards of what I normally write. And you know what is missing? The equal to C. So here is company B equation, or I can always rewrite it as C equals 40D plus 60. And so this second time that I'm writing it is a little bit more similar to the slope-intercept form equation. Now we're going to complete the table and graph the functions. So if I take a look at company A in their table. So, oops, trying to scroll down a little bit. For 0 days, all I'm doing is I'm substituting 0 in for D in solving. So 0 times 40 is 0. 1 times 40 is 40. 2 times 40 is 80. 3 times 40 is 120. We're jumping to 5. 5 times 40 is 200. So again, all I did was I substituted all of my D values into D of the equation and solved. Now if I take a look at the table for company B, I see I'm missing my D values. So to have a good comparison, because a lot of times we do compare functions, this is one of those cases, I'm going to use the exact same D values that are given to me in the first table. So I'm going to go ahead and recopy 0, 1, 2, 3, 5. Okay, and now we're going to do the same thing. I'm going to substitute 0 in for D and simplify. So 0 times 40 is 0 plus 60. I'm left with 60. So on all of these, one way to do this is I can take all of my values from table 1 and just add 60 to it. So that is one way to do it, or just individually redo 1 times 40 is 40 plus 60. I get the 100. But again, I think it's easier just, I have 80 already. I add 60 to it. I have 140. And then 120 plus 60 is 180. And then 200 plus 60 is 260. Now the last, or the next thing that they tell me to do is to create the table and graph the function. So if I scroll down, I'm going to take a look at this table. Now the first thing that I notice with this table is my values. My intervals are labeled, but my axes are not labeled. So we're going to label these axes. So my x-axis is the number of days. And so for you guys, it's very easy to turn your paper and write in your y axis, but I'm going to try and write sideways as neatly as possible. So I have my cost, and so my cost is in dollars. So I'm going to just go ahead and write that in, that it is in dollars. Okay, so just being clear, we're not taking any shortcuts by just writing a dollar sign or anything. Again, we're going to be very clear. Now let's go ahead and label this. I'm going to use two different colored markers and then label my equations as well as I do this. So starting with company A, it has 0, 0, so I can go ahead and mark 0, 0. Then I have at day 1, it is $40. Okay, notice the interval change along your y-axis. My second day, it is $80. My third day, it is $120. Fourth day is skipped, and then my fifth day is $200. So using this information, I'm going to use my ruler. You're going to use your ruler, and we're going to connect all these dots and have it extend through the graph. So I have kind of a ruler built in on this smartboard, and so there's that for me. And like I said, I'm also going to label this equation. So this first equation is C equals 40D. Now for my second equation and my second table, I'm going to go ahead and work on that one. So their starting cost is at 60, sorry. So it is 0.60, and then they jump to 100, 140, 180, and then 260 on the fifth day. So same thing, use your ruler, connect those dots, extend it through the graph, and then label. So I'm going to scroll down so I can reach. There we go. And on this one, it is C equals 40D plus 60. So that's my second equation for the second line. There we go. Now the last thing is it says describe the x-intercept, describe the y-intercept. So notice company B, it does not have an x-intercept, so I'm going to go ahead and write in that company B has none, okay? And then for company A, I'm just going to go ahead and write it under the y-intercept because it can share. As we describe the y-intercept, we are going to combine both the interpretations of the axes as we describe this. So for the y-intercept, for both of them, it is before any days of moving, the starting cost of both moving truck companies. So this is nice. We can combine both, where we are going to say before any days of moving, so again, the starting cost of both moving truck companies. All right, when you're done copying this all down, let's flip to the second page. So for our second example, we're going to write an algebraic equation for the altitude d based on the number of minutes m. We have airplane A is at an altitude of 30,000 feet and descending at a rate of 1,000 feet per minute. Airplane B is at an altitude of 20,000 feet and I started reading my answer key. So for airplane B, they don't have the story problem. We're going to have to go back and fill that in. And so for airplane A, we just get the story problem. We'll fill everything out. Airplane B, they give us all the answers for the table, and then we'll work backwards to get the equation and the story problem. Alrighty then, let's start with airplane A. They have D. D equals. And so it tells us that it's at a starting altitude of 30,000 feet. So we can go ahead and start writing that in. And then descending. So descending sounds a lot like a negative slope. So I'm going to go ahead and write in that minus of 1,000 feet per minute. 1,000 feet per minute. There we go. And if we wanted to, we could always rewrite it in the y equals mx plus b form, where we have 1,000 m, negative 1,000 m plus 30,000. Okay, let's go ahead and complete the table. And so when I complete the table, remember, we're just like our first problem, we're going to compare the two tables. And if I look at my second table, you know, their minutes starts at 0, but then it jumps by 2. So it's 2, 4, 6, 8. Again, I'm coming up with the values of my table by comparing the second table that's already completed for us. So, at 0, I'm at 30,000 feet, so that's my starting point. So again, when I am doing this, my slope is 1,000 feet per minute, but my table has me going by per 2 minutes. So do you guys see that? My change is by 2 minutes. I'm trying to write that in here. It's a little sloppy, but it's by 2 minutes. And so because my change is by 2 minutes, my y-intercept also has to kind of change by the same ratio or same rate, okay? So kind of mental math, you don't have to write this out, but remember how it's, you know, 1,000 feet per minute. If it is going to change by 2 minutes, the numerator here, I'm going to have to multiply it by 2. So I have by 2,000. So what this tells me is at 30,000 feet, every 2 minutes, I'm going to descend by 2,000. Okay, so that was the whole point. So I have 28,000 here. And then if I keep descending by 2,000, I have 26,000. Then 24,000. And then lastly, 22,000. Okay. So again, just maintaining the ratio that was given to me for the slope. The reason we're going by 2s is that if I look at the table for airplane B, they went by 2s, and we're always going to do that for comparison purposes. All right, I'm going to erase my scratch work here. Okay, and so far I have the story problem, equation, and table completed for airplane A. For airplane B, I'm going to backtrack and kind of get all of that done before we graph, and we'll graph both of them together. So for airplane B, if I take a look at my minutes, it is increasing by 2. Okay. Again, remember we go x, y. If I'm talking about my slope, to create with my slope equation, my denominator is 2. My altitude is decreasing by 1,000. So every 2 minutes, airplane B is decreasing by 1,000. Okay, and I see that is constant all the way down. So this is my slope. Remember, I guess real quick, slope is always change of y over the change of x. If I want to simplify this, so again, I'm decreasing every 1,000 feet every 2 minutes. This is the same thing as I'm decreasing every 500 feet per 1 minute. Again, a good way to compare the two airplanes. So if I want to create my equation for airplane B, it is d equals, okay, that's my y, my altitude. My slope, my rate of descending is 500 minutes, or m, but I start at 20,000 feet, okay? If I put this into words, so airplane, so again, I'm just working backwards on this one, is at an altitude of 20,000 feet. And descending at a rate of 500 feet per minute. So again, the point of these notes, we're going to put all story problems, equations, tables, graphs together so you can see the connection that way. But at the same time, we are comparing both relationships. So that's why our tables are matching up. We're comparing both the equations and the story problems. Okay, so to jump down to the table, to the graph, the first thing we're going to do is we're going to label our axes. And so to start with my x-axis, we can use that table to help us, where it is the number of minutes. And my y-axis is my altitude in feet. There we go. Okay, and then go ahead, plot your points and graph this. I'm going to start with airplane A. Airplane A is starting at an altitude of 30,000 feet. And every 2 minutes, it is going down by 2,000 feet. Use your table to help you. And so since this is such a large graph, I'm going to go ahead and keep plotting my dots. That way when I use the ruler to go graph these points, I know it's going to be exact. So now as I use my ruler, I'm going to go all the way down to the very end, again, taking up the entire space of my graph. You're going to go ahead and label this line. I'm just going to call it airplane A this time. We could put in the equation if we want, but I'm just going to label it airplane A. All right, and then we're going to do the same thing for airplane B. So when it starts to descend, it is at 20,000 feet, and every 2 minutes it goes down 1,000 feet. So I have to kind of get that like halfway point. That's kind of hard to do, but I know at every 4 minutes I'm going to get to an even number so I can get right on that grid. So instead of plotting what happens at 6 minutes, I'm going to jump to 8 minutes. And at 8 minutes, I know that I'm at 16,000 feet. So that's what I'm going to keep doing. And another way to think about this is, again, use the concepts of slope. We're going down 1, right 2. Down 1, right 2. So we're going to, again, keep doing that. And again, we're going to use the entire grid. We're not, and this is, again, the point of why we don't do short little lines. We're going to use the entire coordinate plane for when we get to these larger story problems right here at the end of the unit. Okay, and then let's go ahead and label this last one. This one is airplane B. I see right now I misspelled. I forgot the R for air. There we go. There's a little R. The last thing that we're going to do here is we're going to describe our intercepts. Okay, so the x-intercepts. My x-intercepts, I'm going to circle this right now in yellow, so hopefully you can see that. And we're going to describe that. And it is, one is at 30 minutes, the other one is at 40 minutes. So if we think about this, hopefully you compare it with what it also represents along the y-axis. So along the y-axis, we're at 0, okay? And if I put this into words, it would be the amount of minutes it took for the airplanes to land or to descend onto the ground, okay? So it is going all the way to the ground. Again, we're at 0 feet right here. Writing down what I just stated, the amount of minutes it took for the airplanes to land, okay, or descend, whichever vocab word you want to use, onto the ground. Okay, and then the y-intercepts. Again, I'm going to go ahead and circle my 2 y-intercepts. Okay, we take a look at those, and If we think about, again, the story problem and what occurred with this graph, hopefully you are thinking that this is the altitude when the airplanes began their descent. And so we are putting more words to this story problem than, you know, we could always say the starting point. Well, again, when there's a story problem involved, we're going to interpret what we see going on and put some good words to it, okay? So put a good scenario. We're doing some common sense to this one, okay? So again, it's the altitudes when the airplanes began their descent, okay? I don't know if it's proper English. You guys can let me know. Maybe it's the altitude, not altitudes. Maybe altitudes because there's two different ones. So again, think about this as you are working on tonight's homework or the homework that corresponds with this. It is not always cut and dry like some of the other math that we do. You definitely have to put some interpretation into it. Okay, so let's flip it over. We're going to go ahead to example number 3. Okay, example number 3, we have 3 different trains leave a train station at the same time. We're going to compare the speeds of the train. So this is a little bit more basic, a little bit more direct of a type of question. We're just comparing the speeds of the train. When we are talking about the speed of the train, in this case, and we can use the graph and the table to really help us figure this out. And then you can also ask your science teacher. Speed is your miles per hour, typically, is like your distance versus time. And so it is a slope. It is a rate, a ratio. And so using the axes and the labels on the table helped us come up with knowing that it is distance over time. Okay, so and that's speed. So starting with train A, our graph. Okay, so again, we're going to remember that slope is the change of y over the change of x. We have to calculate from one point on our grid to the next. And so I'm going to go ahead and just, pick this, really just pick any 2 points on your grid. And when I go from one point to the next, I'm taking a look at my axes. They jump by 20. So I go up 1, 2, 3. So 3 times 20 is 60. Okay, so I went up 60 miles for my distance. And I went right, and so my time is per hours, 1, 2 hours. Okay, so it is 60 over 2. The other way that you could have done it is you could just find the actual points and use the slope formula to help you come up with that. So if I wanted to do it that way, I have, the point 0, 0. Okay, maybe starting with an easier point. And my second point is 260. Okay, and if I subtract, I still get 60 over 2. We're going to simplify all the way down. We have 30, okay, miles per hour. Okay, using the units when they give it to us. Train B, they just give us an equation. It is going to be 45 miles per hour. And our last one, okay, again, when we talk about slope, change of y over the change of x. The change of my x, if I I can't even talk. Take a look at all 3. They change by 3. Okay, they increase by 3. So I'm going to put 3 for my change of x. And then if I take a look at my y values, my distance, these all increase by 105. Okay, 105. And again, I'm going to simplify this all the way down so we can compare. And 105 divided by 3 is 35. Okay, so a reminder, whenever we are comparing, our numbers need to be in the same format. So we're going to write a sentence to compare the speeds of the train. We can talk about how train A is the fastest at 30 miles per hour. Okay, so train A is the fastest. Okay, and I'm just going to go ahead and write in 30 miles per hour. Then train C, okay, this was at 35 miles per hour. I am so off. What am I thinking? I have this backwards. You're probably thinking I'm crazy. It is not train A at 30 miles per hour. Okay, this is train B is the fastest at 45 miles per hour. Then train B is the slowest. I mean train A. My answer key is wrong. This is at 30 miles per hour. Okay? So there we go. We compare it and we're going to put a simple sentence to it. Example number 4. The equation y equals Lx represents the calories Jake burns when he is cross-country skiing, where x is time. In minutes, y is the number of calories. The graph shows the calories he burns while playing basketball. Which activity burns calories at a faster rate? We are to explain. Okay, so a couple of things to keep in mind. We have the equation y equals Lx, 11x, and this is for cross-country skiing. Then we have x is time in minutes, y is the number of calories. So we're going to remember that. And then this graph over here, this is for basketball. So let's go ahead again to compare how many calories per minute. We need to figure out the slope for this one. And so what I noticed for basketball is the first thing that they do is that they give it to me in hours. The next thing, so let's go ahead. I'm just going to remember that to convert at the very end. My first point is 0, 0. My second point on my grid is right about here. And so that looks like it's 1,500. Okay? And so when I talk about slope, change of y over the change of x, my change of y, 1,500. My change of x is 2. If I simplify, I have 750 over 1. Okay, but again, that's per hour. When x is comparing everything in minutes. We know that from the story problem. So I'm going to take 750, divide that by 60, and this is something you're going to need your calculator for. We have 12.5 calories per minute. Okay, so basketball seems to be burning more calories than the cross-country skiing, and so we'll go ahead and explain that. So so it is burning calories at a rate of 12.5 calories, I'm abbreviating, per minute, which is more than skiing. And we're going to put this all in our sentence, okay? We're going to have a clear thought. We can't just say that it burns more calories. We are comparing two different sports, and so we're saying it's more than the other sport, than skiing specifically. And then skiing only burns at a rate of 11 calories per minute. Okay, so again, real quick before I end this part of the video, I know in English language arts, whenever you guys are writing paragraphs, you have a main idea, you have to have supporting paragraphs. This is the same idea. You have to have supporting bits of information here in math for why basketball is burning more than skiing. Okay, so we're putting all of our information, all of the supporting information. And I think, you know, even in science, your teachers tell you the same thing. So example number 5, you actually had something similar to this earlier in the year with on one of your review worksheets. And so you're going to try and order the stocks from least to greatest rate of price increase, okay? So I'm going to have you guys try this one on your own. So again, you're going to take a look at those slopes. Look at the rate, because again, another word for slope is a rate, and try and put them in order. And then we'll go over this in class the next time I see you. All right, that's it.